In 9.7, we are beginning to use trig identities. And so let's go back to our unit circle and this triangle here. We remember sine, cosine, and tangent. And remember sine always represents our y value. Sine represents our y value, cosine represents our x value. So in relation to the triangle we're given here, now this is a unit circle, and so we're just looking at the first quadrant. Remember that, first of all, sine is our y value. So we try to figure out what is that in this triangle. So the y value is here. So this is our sine value, so we'll say sine of theta. Our cosine then is our x value, which is this triangle here, cosine theta. Then we remember that c is actually our radius. So c is our radius. And then with the unit circle, we have to remember, what is that radius? Unit circle means that the radius equals 1. And so if we're trying to figure out any sides of these triangles, we use the Pythagorean Theorem. So remember that the Pythagorean Theorem is a squared plus b squared equals c squared. So now instead of writing it as a squared plus b squared equals c squared, let's write it in relation to our sine, cosine, and our radius of 1. So our a value, so if we're trying to figure out c squared, our a is really just our cosine. So let's say a squared is now cosine squared of theta. Now just looking at this, just so you can see the notation, cosine theta squared, you will normally see that written as cosine squared of theta. Those are the exact same things, okay? So when we have cosine squared, it's cosine squared of theta. Then we have sine squared of theta, which is our b, sine squared of theta. Then we have our radius r, which is c squared, right here. It's 1 squared. So if we simplify that, that is going to be, cosine squared of theta plus sine squared of theta equals 1 squared, which is 1. So this is one of our Pythagorean identities, and we use this quite a bit. So let's prove that this is true below. So if we have that our Pythagorean identity is cosine squared of theta plus cosine squared of theta, okay, and if you notice over here, it says sine squared of theta plus cosine squared of theta. It's the same thing. It's like saying 3 plus 4 is the same as 4 plus 3, right? So we will take a look at sine squared of theta plus cosine squared of theta. So let's take a look at these in all of the quadrants. So in quadrant 1, let's pick our 45 degrees or the pi over 4. And we're just going to see if this is true, if this holds true. Pi over 4, we remember that y and the x value is the same. It's root 2 over 2 and root 2 over 2. So let's take root 2 over 2 squared times root 2 over 2 squared. So when you square this, you get 2 over 4, and then this is 2 over 4. So you add those together, 2 over 4 plus 2 over 4, that in fact equals 1. Okay, so let's pick something in quadrant 2. Let's pick, let's see, 3 pi over 4. It's the same thing. Let's just do 3 pi over 4, 3 pi over 4. And so our y value is still positive, root 2 over 2 squared. And then the x value is negative, so it's negative root 2 over 2. Now there's a parentheses because you have to square it, right? Order of operations. And so this is still going to be a positive 2 over 4. And this is still a 2 over 4, which means when I add them together, it'll equal 1. If I try another quadrant, let's see quadrant 3. At 7 pi over 6, which is our 30 degrees. And so at 30 degrees, the y value is negative a half squared, and then the x value is negative 3 halves squared. So if you square that, this is 1 over 4, and this squared is positive 3 over 4, and again, the answer is 1. If we kept on going and picked something in quadrant 4, if we picked something over 3, it would be the same thing. It would always equal 1. So that's why we have this identity. It is true. It is always true in the unit circle. So our Pythagorean identity is sine squared of theta plus cosine squared of theta equals 1. Now, knowing this one identity, we can derive the other two. So let's write that again. Sine squared of theta plus cosine squared of theta equals 1. Now let's go ahead and divide everything by cosine squared of theta and see what happens. Cosine squared of theta to every single term. So if you remember, sine over cosine, that is tangent, and it's squared of theta. Cosine over cosine, that just becomes 1. And then 1 over cosine squared of theta, that is secant squared of theta. So here's another one of our Pythagorean identities. So let's go back to the sine squared of theta, and let's this time divide by sine. So we have sine squared of theta plus cosine squared of theta equals 1. Let's divide it instead by sine squared of theta and see what we get. So this becomes sine over sine is 1 plus cosine over sine is cotangent squared of theta. Cotangent squared of theta. And 1 over sine is cosecant squared of theta. And here is our third Pythagorean identity. With all these identities, you can always manipulate them to make it what you need. So for example, we could subtract tan squared of theta. So 1 equals secant squared of theta minus tangent squared of theta. You could subtract 1 from both sides for this top one, and you would get tan squared of theta equals secant squared of theta minus 1. So there's ways that you can manipulate it, and we will use that in this section. So our Pythagorean identity are the sine squared of theta, sine squared of theta plus cosine squared of theta equals 1. Then we'll do the 1 plus first. 1 plus tangent squared of theta equals secant squared of theta. Then the last one is 1 plus cotangent squared of theta equals cosecant squared of theta. In the next video, I'll give you the other identities that you need to memorize.